I'm Dave Shane from Boston Engineering, and I'm honored to present at the 2020 Undersea Warfare Virtual Conference. I'll be discussing gaps, technologies, and approaches to support evolving national defense needs. Specifically in this presentation, I'll start with a very brief company overview. Then I'll introduce opportunities and gaps with respect to our UUV posture. Next, I'll review some non-conventional UUVs and introduce our next generation profiling devices. Lastly, I'll describe a collaboration between the two and how Boston Engineering is constructing missions to support gray zone conflict. Boston Engineering provides product design and engineering consulting from TRL 0 to TRL 9. We've been helping clients solve their toughest innovation challenges for the past 25 years, and we're proud to play a role in advancing new capabilities for the United States Navy. We have significant focus on maritime innovation, from early stage R&D through development and enhancement of critical maritime technologies that address capabilities for the warfighter. We're also enabling smart, connected technologies such as Internet of Things and augmented reality for the DoD and other clients. You can see our technical centers of excellence here. We've worked inside the Department of Defense for NAVSEA, ONR, DARPA, the Army, and others. As a small business, we team with universities and primes. One of our major maritime foci is developing naval capabilities to access congested, contested environments, and then to execute effects once access is achieved. This includes sensing platforms, actuation and manipulation on said platforms, AUVs and UUVs, and I'll talk a little bit more about some of these capabilities in a few minutes. Over the last decade, the UUV space has broadened in terms of vehicle size and capability. However, the mission set has minimally expanded. UUVs ranging from small to extra large are shown at left, per NAVSEA's roadmap. The missions for these vehicles are depicted in the word cloud at the right. Many of the smaller vehicles are used or plan to be used for basic ISR, where the larger vehicles include more effects-based tasking, such as electronic warfare or strike functions. Boston Engineering believes there are two items that drive this divide. First, access into contested environments, and second, the capability to execute effects once access has been achieved. From Boston Engineering's perspective, the current UUV landscape can be plotted with respect to mission type and access capability. As expected, the larger platforms that are more strike capable operate at the left of this access spectrum, and the platforms that are used predominantly for data missions are generally smaller, moving to the right of the spectrum. This generates an opportunity gap with respect to effects-driven missions with platforms that have a high level of access. We see three requirements to satisfy the opportunity gap. First, being able to operate in a clandestine manner will enable port, harbor ingress and egress, and opportunities to integrate with soft forces. Second, submerged operations in hard-to-reach areas require flexible and dynamic path planning and obstacle detection and avoidance. And third, executing effects requires the ability to access specific locations, most importantly, access that last mile. And for many of these missions, that means the last foot or the last inch. So how do we address this opportunity gap? Let's start by talking about non-conventional systems. Non-conventional systems can leverage unique capabilities to expand mission sets. While not limited to biologically inspired systems, this is a good area to discuss the benefits of these non-conventional systems. We can look to systems that mimic amphibious creatures to help connect the shore and sea. We can look to organisms that naturally profile and freely move in an aquatic environment to support oceanographic missions. We can look to large, maneuverable maritime creatures to support more aggressive hydrodynamic control surfaces. It's a reality that there are mission areas where non-conventional systems provide unique and inherent value. We believe that the current thinking is driven by a mentality of incremental innovation versus a more radical innovation approach. It's not to say that standard UUV systems are the incorrect path. Frankly, they've proven their utility many times over. We believe the community needs to open up the aperture with respect to different form factors, different payloads, different approaches to missions, and more broadly, different ways of thinking. Boston Engineering's non-conventional UUV demonstrates this value in many areas. By using inspiration from the tuna, the vehicle has the ability to nominally move like standard UUVs when it needs to, but also allow for very tight maneuvering as appropriate. This also gives us an opportunity to collect unique data along a complex path at a closer range with ease. These systems are highly maneuverable, can get into and out of places others cannot. They can complete longer missions faster, and dependent on configuration, can be covert and capable, doing more without detection. Next, I'll talk about some other oceanographic interests, such as maritime profiling and the requirements thereof. Data that describes the scientific condition of our oceans is critical. Hurricanes cause astronomical losses in both lives and damages. There's significant investment in storm modeling every year, but we still struggle with accurate and timely predictions. Unfortunately, ocean data collection methods are lacking. Current techniques include single profile systems, which are launched off of ships and require personnel on site. As a result, these single profile systems come with very high costs for deployment. Other options, such as buoys, allow sensors to descend and ascend in what are called profiles. This provides significant amounts of data, but the buoy is in a single location and also very expensive to manufacture and deploy. Boston Engineering is developing modular, multi-mission profilers that include multiple payloads, are designed as reconfigurable, and are built for harsh marine environments. There are a range of deployment approaches, and the profiler product family includes both expendable and retrievable variants. Expanding on the oceanographic need, there are additionally Navy-specific needs that span a range of technical and mission spaces. Let me talk for a moment about the multiple variants that Boston Engineering is developing. MAZED is the first product to collect ocean data during developing hurricanes via multiple submerge and surface cycles. SVP Sonde is a low-cost MAZED variant that provides sound velocity profiles, conductivity readings, support of United States Navy littoral combat ship operations. Proteus is a persistent ocean profiling system that gathers high-density measurements through hundreds of profiles over the course of many months to provide the Navy with accurate, year-round ocean environment data at a lower cost than today's methods. Medusa is an autonomous jellyfish-inspired vehicle capable of conducting station keeping in dynamic environments and act as an oceanographic sensor node for 2 to 12 months. The line between military conflict and peace has been blurred, creating a so-called gray zone. This blurred line is requiring us to think differently. Conflicts continue to reside in the gray zone, requiring capabilities to support assessment, monitoring, and information gathering across a range of maritime environments and applications. These include monitoring of sensitive environmental regions, supporting intelligence gathering, deployment of signal and sensing payloads, and monitoring for freedom of navigation. How do we stay nimble and adaptable to these evolving conflict dynamics? The keys are in the application of a range of desired effects throughout the mission and the adaptability inherent in the systems to support changing environment. Specifically, we need capability at a distance, the ability to provide offset from U.S. assets, and we need platforms that are capable of autonomy. The range of abilities can be adjusted or tuned within the last mile. A combination of novel UUVs, multi-mission sondes, and multi-mission payloads provide a mission-tailored solution with the ability to adjust course, such as target or tasking in situ. Non-conventional UUVs, and other non-conventional systems for that matter, often present a broader range of inherent capabilities than standard systems, providing mission planners with multiple options to support various objectives. Secondary deployed systems, such as SONs, can provide expanded capacity and the opportunity for distributed operations. Payloads related to either the UUVs or the deployed SONs can help support sensing, collaboration, or interfacing with a desired effect. With appropriate planning, the team can support a range of missions at the point of need, enabling adjustment or modification of mission up until the effect is administered. To highlight the capability of an effects web, a diverse and scalable effects offering, and to truly step outside the boundaries of historically ISR-based roles, Boston Engineering is in the process of executing our own testing of such a new mission. Based on our planned demonstration at the now canceled Antex 2020 in Newport, Rhode Island, in our own demonstration planned for late 2020, we will showcase our ability to link autonomous subsea profilers to a GoSwimmer AUV for synchronized and tactically relevant demonstration. Our mission plan at this time consists of an underwater vehicle and a deployed sonde. First, a pre-programmed GoSwimmer AUV will be deployed into the harbor via small craft. The vehicle will transit towards shore, collecting oceanographic and hydrographic data in the VSW region. Upon reaching its target location, the vehicle will maneuver out of this region and deploy a profiling sensor. While feasible to execute secondary operations against a local target ship or other actions, this demonstration will include the AUV to exfil to a predetermined recovery point. Once the profiling sensor has been deployed, it will surface to make initial GPS SATCOM connections. Then the system will execute multiple vertical profiles down to available depths, collecting additional oceanographic and perhaps acoustic data. The expected data outputs of this mission include both shoreline characterization and synchronized oceanographic and hydrographic data collected and reported back to an operations center. If there's interest in attending or expanding this demonstration, please reach out. Boston Engineering considers innovative application of non-conventional systems and UUVs imperative to the national defense strategy, specifically increasing lethality for the warfighter, forward maneuver and posture resilience, and improving affordability. Boston Engineering also considers remote maritime sensing to be an important capability moving forward, and consider both control of the data and rapid access to new and emerging data as critical. Boston Engineering requests attendees and Navy leadership to consider requirements for large platforms to deploy non-conventional systems, to drive development of payloads and effects that can be deployed by non-conventional systems, and to develop ConOps and operational concepts that include these non-conventional systems. It's core to the National Defense Strategy to ensure focus and investment to support these systems. Thank you very much for your time.